Hello, my name is Jared Mahoney, and today I'll be explaining a term you may have heard, Ohm's Law. This is one of the very first things that electrical engineering students learn, and it is fundamental to all circuit analysis and theory, from a simple battery connected to an LED to the efficiency of the entire power grid. Now, Ohm's Law is a lot simpler than you might think given the importance of it. Mathematically speaking, it states that the voltage across a resistance is equal to the value of the resistance multiplied by the current through it. What is actually going on here is that a voltage is supplied, and the current through the resistance is limited by the resistance, hence its name. To understand this a little better, let's look at a basic city water system. Voltage is electric potential, which means that it creates a force that in turn causes electrons to move, creating current. This is analogous to the gravitational potential of our water system. By pumping the water up into tall towers, we create a gravitational potential that in turn creates the water pressure which moves water through the pipes to our faucet. It follows that the electric current through our circuit is analogous to the water flowing through the pipes. Current is a measure of how much charge, or the number of electrons, travels through a given area in 1 second. Naturally, this is like how water flow is measured in how many gallons per minute flow through a given area. Lastly, we have the resistance. In the case of our water pipe, consider if we have a section of the pipe that is smaller than the rest. Because the pipe is smaller, less water can flow through it. We can make the same amount flow through by increasing the water pressure, however. We could also intentionally use different pipe sizes to control how much water flows through at any given section. Resistance can come from the size of the wire we use, like the size of the pipe in water, but also from material properties. The less conductive a material is, the more resistive it is. For example, consider trying to run electricity through glass versus copper. Ohm's law has a lot of applications as mentioned before. We use it in circuit analysis, to reduce electricity that is naturally wasted heating up long power lines, to develop efficient electronics, and to control, like with our water pipe size, the voltage and current at different points in circuits, as needed for different components. For example, a 9-volt battery connected to an LED will destroy it almost instantly. To prevent this, we can look at the voltage drop that the LED will cause and pick a resistor value that will drop the rest of our 9 volts so that we don't supply too much to the LED, allowing it to light up instead of burn up. Coming back to power line losses, Ohm's law is a very important application here. The transformers that you see in power stations and on the pole outside your house are there to increase voltage, and thus proportionally reduce current for power transmission, then bring the voltage back down to a safe level for your house, proportionally increasing the current supplied to it. Because power lines are not made out of superconductors, they have a small resistance. When you add this up over tens or hundreds of miles, this resistance becomes quite important. The resistance causes the power line to heat up, wasting some of the power that it is carrying. Ohm's law provides us with a relationship that lets us reduce the current in the line for these long transmissions, thus reducing how much power is lost. Consider how electricity is produced in the United States. While generation varies from region to region, overall about 2/3 of our power comes from burning coal and natural gas, and a small amount from other fossil fuel sources. As a result of this, power generation is the largest individual contributor to greenhouse gas emission, responsible for a massive 30%. We can now see just how important this simple electrical law becomes. By reducing the wasted energy in transmitting electricity, we don't have to produce as much. If we did not take advantage of Ohm's law, much more power would need to be generated to accommodate the transmission losses on top of the electricity that is actually used. I hope now that you understand Ohm's law a little better and some of the applications of it, and how important it is to our everyday lives.